Okay, so we're going to finish off chapter 11. Remember that your diploma exam is tomorrow morning. It starts at 9, but you want to be here a little bit early for instructions and clearing of the calculators. And I told you guys yesterday that after school today, if you have the time, you can come back and I'll review at least Unit 1. Okay? Yeah, I'll record it and post it, you bet. Okay? So also remember that today, by the end of the day, you need to hand in that chapters 9 through 11 review assignment. That's going to determine your mark for this unit. I told you that I would weight it as half of a unit exam, so it's a good chance to boost your mark for sure. All right, so let's do some more questions with binomial theorem. We're asked for the third term in the expansion of that binomial. And remember, oh, Josiah, you are here. I didn't see you back there. So we can do this using the general term formula. And that is T sub k plus 1 equals NCK x, which refers to the first term of the binomial, that's raised to the power n minus k. Y refers to the second term of the binomial, which is raised to the power k. So for question B, we need to find the third term, which means that k would have to be 2. We said that k is always 1 less than the term number. And again, it comes from this T sub k plus 1. If you want to find term 3, then you need to let k equal 2. The 2 plus 1 will equal 3. So for term 3, k equals 2. And you're going to have 6c2 because n is the power on the binomial. X refers to the first term of the binomial, 4b to the n minus k. Y again refers to the second term of the binomial, which is a negative 5. You need to have that as a negative 5 raised to the power of k, which again is 2. So 6c2 is 15. You're going to have 4b all to the power 4. When you raise 4 to the power 4, I think that's 256. 4 to the power 4. Yep. So that'll be 256b to the fourth. And then when you square all of negative 5, you'll get positive 25. So to find out what our coefficient is, we have to multiply the 256 by the 15 and the positive 25. And this gives us an initial, or a coefficient of 96,000. B to the fourth. Right? So there's your answer to part B, the third term in that expansion. Part C now. In the expansion of a squared minus 1 over a to the fifth, which term in simplified form contains a? And that means a to the power 1. That's what it means. A to the power 1. So we're starting with a squared minus 1 over a to the power fifth. So what I would do for that is I would first say, well, 1 over a is a to the negative 1. 1 over a is a to the negative 1. Now this is different than the previous question because we're not asked to find a specific term number. We have to determine or figure out what the proper term is. Which term will have a to the power 1? And what makes this one a little unique is because if you did the entire expansion here, in every term you'd have an a to a positive exponent multiplied by an a to a negative exponent. Each term, if you did the entire expansion, would have an a to a positive exponent times an a to a negative exponent. You'd simplify those by adding the exponents together, and that would give you the simplified power on a for each term. So it's not really straightforward how we can find out what the value or which term contains the a or a to the power 1. So let's start with the general term formula. We know that n is 5. So every term in the expansion would be 5ck a squared to the 5 minus k, and then a to the negative 1 to the power k. Every term in the expansion could be determined by using this expression, just changing the values of k. We can simplify this. So first, the a squared to the 5 minus k, I can multiply those exponents out and get 10 take away 2k. And then I can multiply the exponents on a to the negative 1 to the power k by, again, multiplying the negative 1 by k. And now I can combine those two a factors. You're multiplying powers with the same base. So you can add the exponents and keep the base the same. And when you add negative 2k and negative 1k together, it gives us minus 3k. So this is like a general term or an expression, again, for every term in this expansion. You just have to change the values of k. The first value of k for the first term would be k equals 0. The second term would be when k is 1. Then k is 2 and 3 all the way up to 5, because that's the n value. Okay, we want to find the term that has a to the power 1, or the exponent on a has to equal 1. So the exponent on a in my general equation is 10 minus 3k. That is the exponent on a. It must equal 1. This is how we determine what the proper k value is. Now again, you could have done the entire expansion and gone back and then look and seen after you simplified everything which term was a to the 1, and you'd have your answer. But using the general term formula, you don't have to do the entire expansion. So if we solve for k here by first subtracting 10 from both sides and then divide both sides by negative 3, we get k equals positive 3. So when k equals 3, we should have our term, that's the a term, or a to the power 1. So all we now have to do is let k equal 3 in this simplified expression that we have there. So it'll be 5c3 a to the 10 minus 3 times 3. 5c3 is 10, and you're going to have a to the 1, or just a. Oh, I'm sorry, I forgot one thing here, and that is I should have written this as a negative a in this bracket here. I didn't do that. This a should have been negative. And so what that means is this negative here is like negative 1. So I should also have had negative 1 to the power k. So I apologize for missing that. Okay, so I should have had a negative 1 to the power k here. It doesn't change the value that k is 3, but then when you let k equal 3 in this expression, you'd also have negative 1 to the power 3, which is negative 1. And so the term is actually negative 10a. So I apologize for missing that negative 1 in front of the a. Okay. Question A on the next part. How many terms are there in that expansion? Well, remember that we found the number of terms is always 1 more than n. So if the power on the binomial is 8, that means there's going to be 9 terms. Question B, what is the value of the fourth term in that expansion? So again, using the general term formula, which is on the formula sheet, we don't have to memorize it, but that's what we're going to use here. Now, if you want the fourth term, that means that k must be 3. T sub k plus 1 must become t sub 4. And that will occur when k equals 3. So again, k is always 1 less than the term number. So n is 8. K is 3, 1 less than the term number. X refers to the first term in the expansion, 2a to the 8 minus 3. Y refers to the second term in the expansion, which is negative 7 to the power 3. So 8c3, 56 times. You're going to have 2a all to the fifth. 2 to the fifth is 32. And negative 7 all cubed will be negative 7 to the power 3 is negative 343. So to get the coefficient, you're going to multiply 56, 32, and negative 343 together. So negative 614, 656. A to the fifth. Right? I'm just going to move this all down here. Actually, maybe I won't. Thank you. Okay. Part C. Use binomial theorem to find the first 4 terms in the expansion of that binomial. So, the first term will have a coefficient initially of 7c0. This is when k is 0. Again, the first term in the binomial 3a is raised to the power 7. The 2b is raised to the power 0. You don't need it there, but that's really what's happening. There's your expression for the first term. The second term will be when k is 1. So the power on 3a decreases by 1. The power on 2b increases by 1. The next term will be 7c2. The power on 3a decreases by 1. The power on 2b increases by 1. So there's the first 3 terms. So now the fourth term would be 7c3. Right? In this case, the value of k is 3, and it's 1 less than the term number. The power on 3a decreases by 1. The power on 2b increases by 1. 7c0, bless you. 7c0, I think, is 1. Yep. So it's going to be 1 3a all to the 7th. So 3 to the power 7, 2187. As well, the a is to the power 7. 2b all to the 0 is just 1. Timesing by 1 changes nothing. 7c1 is 7. And then you're going to have 3 to the power 6, which is 729. A to the 6th times 2b to the 1, or just 2b, plus 7c2 is 21. The 3a all to the power 5. So 3 to the power 5. Try that again. Is 243. A to the 5th times 2b all squared, which will be 4b squared. Plus, the last term is 7c3. That's 35. 3a all to the power 4 is 81. A to the 4th. 2b all cubed is 8b cubed. And so now we'll just multiply everything out to get our final 4 terms. Our final answer for our 4 terms. So that second term, the coefficient will be 7 times 729 times 2, 10,206. A to the 6th b. The next term, the coefficient will be the product of 21, 243, and 4, 20,412. A to the 5th b squared. And the last term, the coefficient will be the product of 31, 35, 81, and 8, 22,680. A to the 4th b cubed. So there's the first 4 terms using binomial expansion. Okay? So we saw earlier that you can use combinations, or you can also use factorials with repetition to solve pathway questions. So you can also, though, use Pascal's triangle. So I'm going to show you all 3. We did some questions before with pathways where we used basically permutations with repetition. So to go from A to B, how many blocks do you have to travel? And remember, you don't start counting until you move. So it doesn't matter which path you choose when you're counting how many blocks it takes to go from A to B. No matter which route you follow, in the end, it'll be the same number of blocks. So for this part, it doesn't matter which way you go, but you're always moving closer to B. So if we start at A and we start counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're going to go a total of 11 blocks, which can be done in 11 factorial ways. However, there's repetition, and we did this before, okay? Remember, you don't start counting until you move, so if we count the number of blocks going north to south, this would be the first one because you don't start counting until you move over 1 block, 2, 3, 4, 5, 6. So there are 6 blocks that are going in the same direction, north and south. So that's repetition, 6 factorial on the bottom. In the same way, we count the number of blocks going west to east. But again, you don't start counting until you move. So the first one would be this one. 1, 2, 3, 4, 5. All those are going the same direction. So it's repetition. So this is one way to get our answer. Okay, one way to get our answer. So we'll have 11 factorial divided by, and in brackets, because I have two factors on the bottom, 6 factorial times 5 factorial. Gives us 462. That's one way to do it. Okay? You can also do it using combinations. And so using combinations, you could say that you're going a total of 11 blocks and you have to choose 6 blocks to go up and down, or down, we'll say north to south. There are 6 blocks here that we counted. So you could say, well, I'm going to choose to go 6 blocks from 11. And if you use the NCR formula, it's 11 factorial over 6 factorial times 11 minus, in fact, I did that in the wrong order. First, it's 11 minus 6, n minus k, which is 5 factorial times k factorial. You see, that's same expression that we have above. Same thing. So you could say you're going 11C6 or 11C5. 11 blocks, you're going to choose 5. Those 5 will be the ones that go from west to east. You'll get the same expression. So you can use combinations. The other option we have here is using Pascal's triangle. Okay, and so here's how this works. You start with the 1 where you're at your starting position. Now, these numbers represent the number of routes you can follow. These will all be 1s along the top because it's all part of the same route. You're not counting how many blocks you're moving, you're counting how many routes you can take. So this would all be part of the same route. That's why those numbers don't change. Same thing if you go down. That's all part of the same route. So the numbers don't change. To get the remaining numbers at the intersection of the blocks, we use Pascal's triangle. 1 plus 1 is 2. There are 2 ways to get to that position. You can go over and down from the start, or you can go down and over. Those are the 2 ways to get there. There are 2 ways. 1 plus 2 would give you 3. Right? There's 2 ways to get here, and then you can go to that position. That's all part of the same path from that 2. Or you can go over and down. That's 3. There are 3 ways to get there. You can go over and down, that's 1. You can go down and over, that's 2. Or you can go over, down, and over. There's your 3rd way. There are 3 ways to get to that point of intersection. 3 plus 1 is 4. There's 4 ways to get there. 4 plus 1 is 5. 5 and 1 is 6. 6 and 1 is 7. There's 7 different ways that you can get to that position. And now we're getting, it's a fairly big number, but you could still list them all. Over and down is 1. Down and over would be our second one. Over 1, down and over is our third. Over 2, down and over is our fourth. Over 4, down, and then over is our fifth, and so on. You get all 7 that way. So you don't need to know what the different routes are. You just need to know how many. And so we'll continue this pattern. Pascal's triangle. 1 plus 2 gives us 3. 3 plus 3 is 6. 6 and 4 is 10, and so on. I'm just continuing using the pattern from Pascal's triangle. $56 and 28 is 84. 1 and 4 is 5. 5 and 10 is 15. That'll be 35. That'll be 70. That'll be 126. and 200. No, 210. 1 and 5 is 6, and so on. $252 plus 210 is $462. Same answer we got using factorials with repetition or combinations. We get the same answer. So when you have questions like A or B, you can follow this process. They are complete rectangular grids. There's no pieces missing. When we look at question C, we cannot use factorials or combinations for question C because it's not a complete rectangular grid, right? In this case here, the person has to go around the tree. So it's not a full, complete rectangular grid. So we cannot use combinations or factorials for question C. We could for question B, though, because it is a complete rectangular grid. So using, let's say, combinations, starting at A, you don't start counting until you move. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 11 choose. 1, 2, 3 we could use. The 3 blocks that you can travel going south to north, because remember you don't start counting until you move. That would be 11 factorial over 11 minus 3, which is 8 factorial, 3 factorial. So that would be one way to do it. So 165 is our answer. You could also say 11C 8 if you wanted to, because there are 8 blocks that go west to east. 1, 2, 3, 4, 5, 6, 7, 8. Again, you don't start counting until you move. So that's why we're not counting that bottom line. But 11C8 would be the same expression. Or the other option, using Pascal's triangle. Starting at A, there'll be ones along the side. On the bottom, I should say, ones all along the side. Because these numbers represent the number of routes that you can follow. These are all part of the same route. So those numbers don't change. But then after that, we start using Pascal's triangle. 1 plus 1 is 2. You see, there's 2 ways you can get to this position. From down there or over here. 2 different ways to get there. You can go up and over and up. That's your 2 ways. And we continue using Pascal's triangle. Four and 6 is 10. 10 and 10 is 20. 1 plus 4 is 5. 5 plus 10 is 15. And you know, if you're not sure which 2 numbers to add together, go backwards. If you want to get to this point right here, the only way you can get there is from the side, which is 15 ways to get there, or from directly below, which is 20 ways to get there. 20 plus 15 is 35. That number there must be 35. So we'll continue. 1 plus 5 is 6. 6 and 15 is 21. 35 and 21 is 56. That'll be 7. 28. 56 and 28 is 84. That'll be 8. That'll be 36. 84 and 6 is 90. Plus 30 is 120. 1 and 8 is 9. 9 and 36 is 45. 45 plus 120 is our 165. So it checks. Okay. Same answer that we got using combinations. 165. So again, we cannot use factorials or combinations for question C because it's not a complete rectangular grid. The person that's going from A to B has to go around the tree. But we're starting at A, and that means they'll all be ones along the top and along the side. Remember, this refers to the number of routes that you can follow. If you go A and head to the right, that's all part of the same route. You're not counting the number of blocks you're moving, you're counting the number of paths or routes that you're following to go from A to B. Same thing with all those ones along the side. So this first row is very straightforward. You're just using the Pascal's triangle pattern. To get to that point right there, you can come from above or from the left. So you'll add the 1 and the 2 together to get 3. To get to this point right here, you can either come from above or from the left. So you'll add the 3 and 3 together to get 6. And now I'm going to stop and move down to the next row. 1 plus 3 is 4. To get to this position, you can either come from above or from the left. So 6 and 4 is 10. To get to this point right here, the only way you can get there is from directly above. So that would also be 4. It's part of the same route. But to get to this corner, you can either come from the left or above, so you have to add the 10 and 4 together and get 14. 5 plus 4 will give us 9 there. 9 and 6 gives us 15 there. 14 and 9 is 23. 23 and 15 is 38. And then the bottom row is just like normal. 1 and 5, 5 and 10, 15 and 14. That'll be 52. 38 and 52 is 90. And there's your answer. 90 different routes could be chosen to get from A to B, going around the tree. Okay? The next one. Find the number of pathways from A to C, but you must go through B. And again, always moving closer to C. So if you must travel through that B intersection, always getting closer to C, you can't go any further right than where I put that last one. Because if you go all the way over, you're going to have to backtrack to get close to go through B. And you can't backtrack. You're always moving closer to C. So in the same way, you can only go down as far as that last one I wrote on the left there. You cannot go any further down initially because then you'd have to backtrack to go through B. And you're always moving closer to C. So that'll be a 2, that'll be a 3. 1 plus 2 is 3, 3 plus 3 is 6. So there's 6 ways to get from A to B. And then we'll continue on then. These would all be 6s because it's part of the same path from B. In the same way, that would be a 6, that would be a 6, and that would be a 6. They're all part of the same path or route from B. And now we need to go from B to C. There would be 12 ways to get there. You can either come from above or from the left. Those are both 6 paths. So now we have a total of 12. 12 and 6 is 18. 18 ways to get there. The only way you can get to this part right here is from directly above. So those numbers are the same. It's part of the same path. But to get to this point, you can either come from above or from the left. So 12 and 18 is 30. To get to this point down here, there's 2 ways you can get there, from above or from the left. So you're going to add the 6 and 12 together and get 18. And then finally, 38 and 18 is 48. And there's the answer to the number of paths that can be followed to get from A to C, where you must go through B. Okay? So that's it. So remember that you need to get your review assignment completed and handed in by the end of the day. Some of you handed in already. If you want to get it back to check those last few questions on past pathways, you can. Okay? If you want. Or if you're fine with it, then that's fine too. So there's no assignment